Deployment of laser technology in combat operations by 2024, a comprehensive overview. Introduction. The integration of laser technology into military operations represents a significant evolution in combat strategy. By 2024, a structured deployment plan is set to unfold involving a $5 million investment for the testing of 50 laser systems. This report outlines the three critical stages of integration, the economic context of the investment, and the implications for modern warfare. 1. Overview of laser technology deployment. The deployment of laser technology in combat operations will occur in three key stages. Stage 1. Initial testing and evaluation 2023 to 2024. The first phase focuses on the testing and evaluation of 50 laser systems in diverse military environments. This will involve conducting field tests to assess the system's effectiveness in real combat scenarios, evaluating performance metrics under varying conditions including different weather patterns and combat situations, gathering data to establish operational parameters, which will inform future integration efforts. Stage 2, Operational Integration 2024. Upon successful testing, the next phase will transition into operational integration. Key components include training military personnel to effectively operate the new laser systems, ensuring compatibility with existing weaponry and military tactics, developing protocols for the use of laser systems in conjunction with traditional weaponry to enhance overall combat effectiveness. Stage 3, Full-Scale Deployment 2025 and beyond. The final phase aims for a comprehensive deployment across various military branches. Objectives will include optimizing laser systems for specific combat roles such as air defense, ground support, and anti-drone operations. Establishing a feedback loop to continuously improve the systems based on operational experiences. Expanding the technology's capabilities to address emerging threats and adapt to evolving warfare tactics. 2. Investment and economic context. The $5 million investment dedicated to this initiative is crucial for its success. Key points include alignment with defense priorities. This funding reflects a broader trend of increasing investments in advanced military technologies, particularly directed energy weapons. Cost effectiveness. Laser systems are expected to reduce logistics and supply chain burdens associated with traditional munitions. The potential for lower operating costs will be a significant factor in military budgeting decisions. Long-term strategic goals. This investment underpins the military's strategic adaptation to modern warfare, emphasizing the need for precision targeting and reduced collateral damage. 3. Common themes across sources. Several themes have emerged in discussions surrounding the deployment of laser technology. Technological advancement. A consensus on the necessity for advanced military capabilities, with laser technology regarded as a pivotal component due to its precision and reduced risk of collateral damage. Interest from defense contractors. Companies such as Anduril and Epirus are significantly contributing to the development of laser and directed energy technologies, highlighting a competitive market among defense contractors. Strategic adaptation. The integration of laser systems signifies a strategic shift in military operations, emphasizing efficiency and effectiveness in contemporary combat environments. 4. Differences between sources. While the overarching narrative remains consistent, different sources highlight various applications and advantages of laser technology. Some sources emphasize cost-effectiveness over traditional weaponry, arguing that lasers could streamline supply chains. Others focus on operational advantages, such as the ability to deliver precise strikes without the risk of explosive damage, particularly relevant in urban warfare scenarios. 5. Timeline of key events. 2023. Initial testing of laser systems begins with a focus on performance evaluation. 2024 Operational integration commences, including personnel training and system compatibility assessments. The $5 million investment is utilized for these activities. 2025 Full-scale deployment of laser systems is anticipated, enhancing military combat capabilities. 6. Future implications. The deployment of laser technology in combat operations by 2024 is expected to significantly transform military strategies. Future implications include enhanced combat capabilities. The ability to conduct operations with increased precision and reduced collateral damage will reshape engagement rules and tactics. Adaptation to emerging threats. As warfare evolves, laser systems may become integral in countering new threats such as swarms of drones or advanced missile technologies. Global military dynamics. The adoption of laser technology may influence global military balance, prompting other nations to accelerate their own advancements in directed energy weapons. Conclusion. The structured deployment of laser technology in combat operations by 2024 signifies a pivotal evolution in military strategy. Through a carefully planned integration process supported by substantial investment, the military demonstrates its commitment to leveraging advanced technologies for enhanced operational effectiveness. As testing and integration progress, the potential for laser systems to revolutionize combat scenarios becomes increasingly apparent, heralding a new era in military engagement. This comprehensive overview underscores the importance of continued investment and innovation in the defense sector to meet the challenges of modern warfare effectively. The deployment of laser technology in combat operations by 2024 involves a structured approach divided into 3 stages. With a $5 million investment aimed at testing 50 laser systems. Here's an analysis that identifies counterintuitive information that emerges from the content. 1. Investment versus expected outcomes. It may seem counterintuitive that a relatively modest investment of $5 million is allocated for testing 50 laser systems, considering the complexity and advanced nature of laser technology. The assumption might be that substantial funding is necessary for cutting-edge military technologies. However, this investment could reflect a strategic approach wherein the military aims to validate and refine technologies before committing to larger budgets for full-scale production and integration. 2. Operational benefits versus traditional weaponry. Many discussions around laser technology emphasize cost-effectiveness over traditional munitions. This perspective may appear counterintuitive because one might expect newer technologies to be more expensive. The idea that lasers can reduce logistics and supply chain burdens challenges conventional wisdom about the economics of warfare, suggesting that long-term operational savings could outweigh initial costs. 3. Precision targeting versus urban warfare risks. The operational advantages of lasers include precision strikes with minimal collateral damage, which is notably critical in urban combat scenarios. This may seem counterintuitive since one might expect that new technologies could introduce additional risks or complexities. However, the focus on precision indicates a shift in military strategy towards minimizing civilian casualties and infrastructure damage, reflecting an evolving understanding of warfare ethics and public perception. 4. Gradual integration versus immediate deployment. The phased approach to integrating laser systems into military operations, testing operational integration and full-scale deployment, might appear overly cautious in a fast-paced technological environment. The counterintuitive aspect here is that rather than rushing to deploy new systems, the military prioritizes thorough testing and training, indicating a recognition that effective implementation is more critical than rapid deployment. 5. Competitive landscape among defense contractors. The interest from defense contractors like Anduril and Epirus in directed energy technologies may seem counterintuitive given the historical dominance of kinetic weapons. One might expect a more cautious approach from these companies in investing in emerging technologies. However, the aggressive pursuit of innovation in laser and directed energy systems indicates a significant shift in market dynamics and a recognition of the potential for lasers to redefine combat capabilities. 6. Strategic military adaptation. The integration of laser systems can be interpreted as a strategic military adaptation to modern warfare's evolving nature. This might seem counterintuitive because one could assume that traditional military strategies would prevail. However, the military's willingness to embrace advanced technologies like lasers demonstrates an understanding that future conflicts will require new tactics and capabilities to address asymmetric threats in complex operational environments. 7. Testing of 50 systems versus technology readiness. The decision to test 50 laser systems may seem excessive when compared to the norm of evaluating fewer prototypes in other technological fields. This approach is counterintuitive in the sense that it reflects an understanding that diverse testing conditions and varied applications are crucial for a comprehensive evaluation of the technology's effectiveness in real-world scenarios. 8. Technological advancement. The emphasis on advanced military capabilities through laser technology suggests a counterintuitive notion that military innovation can occur at a pace that outstrips traditional procurement processes. This may challenge the perception that military technology development is slow and bureaucratic, indicating a shift towards a more agile and responsive innovation culture within military organizations. 9. Focus on collaboration between tech and defense. The growing interest from tech companies in military applications, particularly in laser technology, may appear counterintuitive given the historical separation between these sectors. The integration of diverse technological expertise into defense systems reflects a recognition that collaboration can yield superior solutions to complex defense challenges. By recognizing these counterintuitive insights, one can appreciate the complexities and strategic considerations involved in the deployment of laser technology in military operations. The integration of such technologies goes beyond mere functionality. It encapsulates economic, ethical, and adaptive military strategies that reflect a changing landscape in warfare. The report on the deployment of laser technology in combat operations by 2024 outlines a significant shift in military capabilities through a structured three-phase integration plan. Backed by a $5 million investment for testing 50 laser systems. While the key themes and overarching goals are highlighted, there are several critical elements that may be overlooked by the general audience. Here are some important points that deserve greater attention and explanation regarding their significance. 1. Precision targeting and reduced collateral damage. One of the most significant advantages of laser technology in combat operations is its potential for precision targeting. Many people might overlook how this capability can dramatically change the nature of warfare, especially in urban environments. Traditional munitions often carry a risk of collateral damage affecting civilians and infrastructure. Lasers, with their focus and accuracy, can minimize these risks by allowing for targeted strikes that are less likely to miss their intended targets. Significance: the ability to conduct operations with minimal collateral damage can enhance a military's ethical standing and reduce the potential for backlash from the international community. This is particularly crucial in an era where public perception of military actions is heavily scrutinized. 2. Cost effectiveness over time. While the initial investment of $5 million for testing might seem modest compared to the costs associated with traditional munitions, the long-term cost effectiveness of laser weapons is a vital aspect that may be underestimated. Laser systems can theoretically operate at a much lower cost per shot once the infrastructure is in place, as they do not require physical ammunition and can utilize electricity as their primary power source. Significance: understanding the financial implications of transitioning to laser technology highlights the potential for military budgets to be reallocated towards other areas such as research and development or personnel training. This shift could result in more sustainable military operations in the long run. 3. Impact on military training and doctrine. The integration of laser systems into military operations will necessitate new training programs and modifications to existing combat tactics. Many reports may skim over the implications this has for military doctrine and the potential need for a cultural shift within armed forces. Significance: the evolution of military training to incorporate new technologies is crucial for maintaining operational effectiveness. A failure to adequately prepare personnel for the use of laser systems could lead to inefficiencies and mishaps in combat scenarios, potentially jeopardizing missions and lives. It highlights the need for continual adaptation and learning within military organizations. 4. Collaborations with defense contractors. The report mentions companies like Anduril and Epirus as key players in the development of laser technology, yet the nuances of these collaborations can be easily overlooked. The competitive landscape among defense contractors signifies a drive for innovation that may influence the speed and effectiveness of laser technology deployment. Significance: the collaboration between military and private sector entities can accelerate the integration of cutting-edge technologies into combat operations. Understanding these dynamics reveals a broader trend in defense, a shift towards public-private partnerships that leverage the agility and expertise of the tech industry to meet military needs. 5. Adaptation to modern warfare. The report emphasizes the strategic military adaptation to modern warfare's evolving nature. But the underlying challenges this brings may not be fully appreciated. As adversaries increasingly adopt asymmetric warfare tactics, the need for advanced technologies like lasers to counter these strategies becomes critical. Significance: acknowledging the changing landscape of warfare underscores the necessity for military innovation. As adversaries leverage technology in unconventional ways, traditional methods of engagement may become obsolete, making the integration of advanced systems like lasers essential for maintaining a tactical advantage. 6. Environmental and operational considerations. While the report does not delve deeply into environmental considerations, the deployment of laser systems could have implications for combat environments, including the potential for reduced environmental impact compared to traditional weapons. Significance: as military operations increasingly face scrutiny regarding their environmental footprint, the shift towards laser technology may present an opportunity to minimize ecological damage during conflicts. This is particularly relevant in regions where military activities can disrupt local ecosystems, highlighting a growing awareness of environmental responsibility in defense strategies. 7. Testing under varied conditions. The initial testing phase involves assessing laser systems across various military settings, which may be seen merely as a procedural step. However, the significance of testing under diverse conditions cannot be understated, as it ensures that the technology can adapt to unpredictable combat scenarios. Significance: comprehensive testing can reveal weaknesses and strengths of laser systems, leading to refinements that enhance reliability and effectiveness. This iterative process is crucial not just for operational success but also for instilling confidence in personnel who will utilize this technology in high-stakes environments. 8. Integration with existing military frameworks. The transition from testing to operational integration involves more than just introducing new technology. It requires a fundamental re-evaluation of existing military frameworks and strategies. The potential resistance to change within military ranks could impede successful integration. Significance: recognizing the challenges of integrating new technologies into established military practices emphasizes the importance of change management. Effective communication and leadership will be critical to ensure that personnel understand the benefits of laser technology and embrace its use in future operations. Conclusion: the deployment of laser technology in combat operations signifies a pivotal transformation in military capabilities. While the report outlines a structured plan for integration, it is essential to recognize the broader implications of this advancement. The significance of precision targeting, cost-effectiveness, training adaptations, contractor collaborations, and environmental considerations cannot be overlooked. These factors collectively shape the future of military operations, underscoring the need for ongoing adaptation and innovation in the face of evolving warfare dynamics. Understanding these nuances is vital for stakeholders involved in defense strategy policymaking and military operations. 1. 3 stages of integration. The deployment of laser technology in combat operations is structured around 3 critical stages: initial testing and evaluation 2023 to 2024, operational integration 2024, and full-scale deployment 2025 and beyond. This phased approach allows for thorough testing of 50 laser systems under diverse military conditions, ensuring that the technology is effective and suitable for integration into existing military frameworks. The gradual training of personnel and optimization for specific combat roles in later stages underscores a strategic commitment to enhancing military capabilities. 2. Economic implications of a $5 million investment. The $5 million investment earmarked for the development and testing of laser systems reflects a broader trend of increasing funding in advanced military technologies, particularly directed energy weapons. This investment is not only pivotal for the immediate testing and integration phases but also signifies an economic commitment to fostering innovation and advancing the U.S. military's technological edge in modern warfare. The potential cost-effectiveness of laser systems over traditional munitions may also reduce logistics and supply chain burdens, making future military operations more efficient. 3. Technological advancements and strategic military adaptation. The focus on laser technology illustrates a significant shift in military strategy, emphasizing the need for precision targeting and reduced collateral damage in combat scenarios. The growing interest from defense contractors, particularly companies like Anduril and Epirus, highlights a competitive landscape where innovation in directed energy technologies can redefine operational capabilities. This strategic adaptation to modern warfare's evolving nature indicates a proactive approach to integrating advanced technologies that enhance the effectiveness and efficiency of military operations. For diverse applications and operational advantages, the discussions surrounding the operational benefits of laser systems reveal a range of applications that extend beyond traditional uses. Some sources underscore the technology's cost-effectiveness compared to conventional munitions, while others emphasize its operational advantages, such as the ability to deliver precise strikes without explosive risks. This versatility is particularly relevant in urban combat settings where minimizing collateral damage is crucial. As such, the integration of laser technology not only augments existing military capabilities but also aligns with contemporary tactical priorities of precision and efficiency in combat operations. 1. The Battle of the Somme 1916. During World War I, the Battle of the Somme marked a significant military operation involving the introduction of new technology in combat. The British Army utilized tanks for the first time in battle, aiming to break the deadlock of trench warfare. The integration of tanks represented a pivotal move towards mechanized warfare, paralleling the modern integration of laser technology in combat operations. The operation highlighted the challenges and potential of deploying new technologies in a combat environment, leading to both tactical innovations and high casualties. 2. The Manhattan Project 1942–1946. This was a research and development project during World War II that produced the first nuclear weapons. It involved multiple stages, including theoretical research, practical experimentation, and eventual deployment. The project required significant investment, scientific collaboration, and strategic planning similar to the proposed 3-stage integration of laser technology. The Manhattan Project's successful outcome fundamentally changed military strategy and international relations, much like how the effective deployment of laser systems could alter modern warfare. 3. Operation Desert Storm 1991. This military operation during the Gulf War showcased the integration of advanced technology in combat, particularly precision-guided munitions and stealth aircraft. The use of these technologies allowed for unprecedented accuracy and effectiveness in operations, minimizing collateral damage. The operational integration of these advanced systems involved extensive testing and training akin to the planned phases of laser technology deployment in contemporary military strategy. The success of Operation Desert Storm demonstrated the potential impact of technological advancements on military operations, setting a precedent for future conflicts. Future outlook. Deployment of laser technology in combat operations by 2024. The anticipated deployment of laser technology in combat operations by 2024 marks a significant shift in military capabilities characterized by a structured integration process and an investment of $5 million for the testing of 50 laser systems. As military strategies evolve, laser technology is positioned to play a pivotal role in modern warfare. Here we explore the predicted advancements and implications of this technology in the coming years. Stage 1, Initial Testing and Evaluation 2023 to 2024. The first stage of deployment entails rigorous testing and evaluation of 50 laser systems across various military environments. This initial phase is crucial for gathering data on performance reliability and operational effectiveness. By the end of 2024, military leaders will have a clearer understanding of how these systems function under diverse combat conditions. The data collected will inform future modifications and optimizations, leading to enhanced system designs. Stage 2, Operational Integration 2024. Following successful evaluations, the second stage will focus on integrating laser systems into existing military frameworks. This phase will involve extensive training programs for personnel, ensuring they are adept at operating the new technology alongside traditional weaponry. The integration process is expected to enhance the military's tactical capabilities, allowing for precision strikes with minimal collateral damage. As military doctrine evolves to incorporate these systems, we may see shifts in engagement strategies, particularly in urban and asymmetric warfare scenarios. Stage 3, Full-Scale Deployment 2025 and beyond. By 2025, full-scale deployment of laser systems across various military branches is anticipated. This will not only optimize combat roles but also redefine mission parameters. Laser technology promises cost-effective solutions by reducing reliance on traditional munitions, thus alleviating logistical burdens. The ability to provide precision targeting without the explosive aftermath will be particularly advantageous in densely populated areas, aligning with the military's growing emphasis on minimizing civilian casualties. Economic context and investment trends. The $5 million investment in laser technology reflects a broader trend of increased funding for advanced military technologies. As defense contractors vie for dominance in the market, companies like Anduril and Epirus are at the forefront, pushing the boundaries of directed energy weapons. This competitive landscape is likely to accelerate the pace of innovation, with enhancements in laser systems expected to emerge rapidly. Key themes and predictions. 1. Technological advancements. As the military integrates laser systems, advancements in optics, power management, and targeting systems will likely emerge. This could include developments in solid-state lasers and advancements in beam focusing technologies, making them even more effective in combat scenarios. 2. Cost efficiency. The long-term cost-effectiveness of laser systems will become increasingly evident as operational data accumulates. The reduced need for ammunition resupply and lower maintenance costs could lead to a strategic shift in budgeting for military operations. 3. Strategic military adaptation. The integration of laser technologies signifies a strategic military adaptation to modern warfare. As threats evolve, the military will continue to innovate, potentially exploring hybrid systems that combine lasers with other emerging technologies such as artificial intelligence and drones for enhanced battlefield effectiveness. For expanded applications, beyond traditional combat roles, laser systems may find applications in non-lethal scenarios such as crowd control or disabling enemy electronics. This versatility could lead to broader acceptance and deployment of laser technology in various operational contexts. 5. International competition and collaboration. As countries around the world recognize the potential of laser technology, we may see increased competition. This could lead to collaborations between nations for joint development projects, sharing of best practices, and co-development of systems that enhance collective security. Conclusion. The future of laser technology in combat operations is poised for dramatic transformation by 2025 and beyond. The structured integration process, coupled with significant investment in testing, underscores the military's commitment to leveraging advanced technologies for enhanced operational effectiveness. As developments unfold, the implications for military strategy, cost efficiency, and international defense dynamics will be profound, potentially reshaping the landscape of modern warfare. This evolution signals not only a shift in how military engagements are conducted but also a broader rethinking of defense strategies in an increasingly complex global environment.